All right, hi everybody. Happy Halloween. I hope everybody's having a good weekend. For anybody who's been wondering, this is what I look like without a mask on. Okay, so what I'm doing today is I wanted to make a couple of quick videos that'll be helpful to you for the exam because I don't really have any more time to work with you before the exam and on the homework. So I'm going to make two videos. In this first one, what I'm going to do is I'm going to demonstrate how to solve a few of the problems from the practice exam. All right. So what I'm going to do now is I'm going to go ahead and share the screen and go into some of those problems. Okay, so this first problem, this is problem 1 in section 2 of the practice exam. So this problem is pretty typical of what you might see on the exam. So it just looks like this. And for this section of the practice exam or of the exam, all you need to do is just carry out this derivation. So you're being told that this problem is valid, that this argument is valid, and you just need to carry out a derivation or a proof. Okay, so let's go ahead and do the proof together. So we'll do this proof two different ways. We'll do it once with just the basic rules, and then we'll do it using the more advanced rules or the derived rules. Okay, so we need to get to P, and there's a couple of different routes that we can take. Actually, I mean, there's a lot of different ways that we can do this, but one option that should immediately suggest itself. Now, look, there's no direct way to get to P. I mean, the first thing you always want to check is, can you get it by reiteration? We obviously can't do it by reiteration. The second thing you want to check is whether you can use any of the non-subproof rules, in particular, these three elimination rules. And we're not in a position to use any of those. You know, we can't use them up here. We don't have the antecedent to use this conditional. You know, there's nothing we can do with this disjunction or this negation. So the third step is you want to look, you know, if your goal is a conditional, you want to use conditional introduction. If it's a biconditional introduction, you know, our goal is not a conditional or a biconditional. And third, you want to look at what you have already in your proof. So look up here and see if you have a disjunction to do disjunction elimination. And in this case, we do have a disjunction. And what this suggests is that we're going to carry out this proof by using disjunction elimination. So what we'll do is you make two subproofs. This is an example of what mathematicians call proof by cases. So what that means is we know either P is true or Q is true. One of those two things is definitely true. That's like an assumption of this argument. And we want to show that P follows from either one. If P is true, you get P. And if Q is true, you get P. So I typically like to start with the one that's going to be easier. In this case, it's pretty obvious that that's P. In the other one, we'll start with Q. And in both cases, you want to derive your goal. So you want to derive P. So the first thing that we want to do is try to get P from P. And, you know, it's pretty obvious how we're going to do that. It's pretty simple. We're going to use reiteration because we already have P. Reiteration just says, hey, we already have it. So that's reiteration line 4, all right? So now this is our line 6, and we want to get P. Okay, so now we have to think a little harder. So how can we do this? Well, we can't get P by reiteration this time because we can't go back up and do this other subproof that ends on line 5. But we do have a non-subproof rule that we can use. We can use conditional elimination to get an S here on line 7. Okay, so we have S by conditional elimination, lines 1 and 6. And we have a problem now because we have not S on line 3, right? So we have a contradiction. We have S and not S, which gives us a falsum by the rule called negation elimination, lines 3 and 7, right? And now remember, if you have a falsum, in that same subproof, you can write whatever you want. You can write whatever you want below a falsum. So we are going to go ahead and write P by the rule called explosion on line 8. And now we can wrap this up and get P by disjunction elimination, lines 2, 4 through 5, and 6 through 9. All right, so I hope that made sense to everybody. If not, of course, this is recorded. You can go back and watch it again. And of course, what I really recommend that you do at every step is to pause the video and see if you can anticipate what I'm about to do before I do it. So let's just look at one other way of solving this problem. We're going to make use of some of the derived rules this time. Okay, so again, we want to get P. So we can make use of the derived rule called modus tollens to get not Q. We have not S, and we have if Q then S, and not S tells us not Q. That's modus tollens, line 1 and 3. And now, because we have not Q, we know we have P or Q here, and we have not Q, therefore we know P by disjunctive syllogism, lines 2 and 4. All right, so that was 2 different ways to solve that problem. Right now, I'm going to pause the recording for a second while I erase the ink on this slide, and then we'll take a look at some of the other problems. Okay, what we're going to do now is take a look at some of the problems from section 3. These are a little bit more difficult. They require a little bit more thought because you're not being told beforehand whether these are valid or not. So and that's just something that you're going to have to determine. So I'm going to talk, there's 3 different ways you can do that. Okay, so what's going to happen is you're going to be given something like this. And you need to figure out whether or not you can actually carry out this proof, whether you can get to here from here. So I'll talk about, there's 3 different ways that you can do this. The first is by doing a truth table. And so method number 1 is just to do a truth table. And I really don't recommend that you do that. If you do that for every problem on the exam, you're definitely going to run out of space. I mean, there's going to be like 3 or 4 problems like this on the exam. Excuse me, not space, but time. You're going to run out of time on the exam, okay? The second method is the short table method. And I did this with you guys a little bit in class on Friday, but let's go ahead and take a look at that again. So what the short table method is you're just going to make one line of the truth table, and you're going to make like an educated guess, or you're going to try to figure out based on the values of the, you're going to try to figure out based on like the values of the letters, whether or not you can come up with a counterexample. So what you're going to do is you're going to make an educated guess at the truth value of these letters in order to find a counterexample. Okay, so remember, a counterexample is a line of the truth table where your premises are true and your conclusion is false. All right, so we need the So we need true premises, false conclusion, all right? So in this case, we're gonna have to do a little bit of work here. This problem is actually not that well suited to this method, all right? Because there's several ways that we can make this true, and there's several ways that we can make this false, but we should start by just making an educated guess, okay? So for this to be false, we need this to be true, right? So remember, we need false conclusion, true premises. So we need this overall to be false, meaning that we need this disjunction to be true. So let's just take a guess. Let's make A true and B true, and that would make this disjunction true and make this false, okay? So we'll try true and true. So that makes this not A false. It makes this not B false. And it makes this true it makes this false. So that is not that's not a counterexample. That's not what we were looking for. So what we can do is we can try another combination here. So let's try making A false and B true. Again, that's going to make this disjunction false, and it's going to make this negation false. Or sorry, it's going to make this disjunction true, so it's going to make this negation false, right? Which is what we want. We're looking for a counterexample, a place where the conclusion is true and the premises are, where the conclusion is false and the premises are true. So now we go over here. This time we're trying A false and B true. Okay, so now this not A is true. And we know right away, not B is still false, but this is true. So we've identified a counterexample here. We have true premises and a false conclusion. And so we know that this argument is invalid. And the counterexample is when we have A false and B true. Okay, so that's a way of doing it. All right, you make as little of the truth table as you can. Usually you'll be able to do this in one line. In this case, it took a couple of tries, but we found our counterexample. All right, so another way to do this is what's called the incomplete table. All right. And if you're not comfortable with that method that I just showed, this may be a little better for you. All right, so in this case, what you're going to do is you're going to start with a complete table, and you're just going to fill out as little of this as you can. Okay, so remember, we're looking for a place where we have true premises, false conclusions. So what we're going to do is we're going to go through this column by column. And as soon as we know that a row is not what we're looking for because we have a false premise or a true conclusion, we just stop and we don't work in that row anymore. All right. So a good place to start, especially if you have multiple premises, is by trying to make the conclusion false. So again, we know there's lots of places this conclusion is false, but let's look here. We have true A, true B, so this is true, this is false, true, false, true, false. Aha, so down here, this is false, so this is true, so we have a true conclusion. So we're not gonna work in that row anymore. So we're just gonna scratch that out. Okay, so we go back up here, and we start evaluating this. So false, false. This is false. Okay, so that's not a counterexample. So let's look here. False, true, true. And so there we have our counterexample. All right. In that case, that method didn't save us a ton of work. Sometimes it's like that, and sometimes it's very helpful. It just depends on the nature of the problem, okay? But in any case, we now know we've identified this just like we did with the short table method, and that's our answer on the exam or whatever. So again, I'm going to pause this for a moment while I erase this slide, and then I'll go into one more problem for the exam, okay? Or for the practice exam. All right, hi everybody, welcome back. I'm gonna do one more problem from the practice exam now to kind of help everybody out getting ready for the exam. Let's go back to the slide. And all right, so this time, this one's a little more complicated. This is problem 3 from section 3 of the practice exam. All right, so here we go. So the first thing you need to do is to figure out whether this is valid or not. Now, if you've been doing this for a while, yeah, you can just kind of look at it and know, but I don't think any of us are quite there yet. So remember, we have those 3 methods that I just talked about on the last slide. You have the full truth table, the partial truth table, or the short truth table. And I'm just going to do the short table method again, because that's the one that I think is best, especially under exam circumstances. And given that we have 3 letters now, this would be an 8-row table. So it's really in our best interest to save ourselves some time, like on the exam, okay? Okay, so remember what we're looking for is a place where the conclusion here is false and the premise is true. Okay, so this, when you have a conditional in the conclusion, this technique works really well because there's only one way this can be false is if you have true premise and false conclusion. So that tells us right away that A must be true and P must be true as well, so that not P can be false. So let's take that information and plug it in over here and see if that tells us anything. So we have, this is true, and P is got to be true as well. We've already decided that, and we don't even need to know the value of Q. That tells us that this disjunction must be true because one of the disjuncts is true. So that negation is false. And that makes this false as well. So it doesn't look like there's any way that we can do this, or we can arrange these letters so that we actually have a true premise and a false conclusion. So this looks valid. We're going to go into trying to do a proof now. If we find that we can't carry out a proof, maybe we did something wrong there and we should go back and reevaluate how we reasoned about that short table. But let's take a look at this. So we have a premise here, which is if A, then not P or Q. And what we're trying to prove is if A, then not P. Okay. So again, there's a couple of ways to do this. Let's try to just do it once with just the basic rules. So we're trying to get a conditional here, and we know right away what to do when we're trying to prove a conditional. What we're going to do is assume the antecedent, and we are going to try to derive the consequent. Okay, so we're starting with A, and we're trying to get not P. We know that by looking at the conclusion here. Okay, so now let's take a look at what we have. You may already see how to do this, but what we're going to, if you didn't know how to, if you had no idea what to do, you should still look at this and see if there's any non-subderivation rules that you can apply. So it looks like, we have the antecedent of this conditional now, so we can do conditional elimination to get this, to get not P or Q, okay? So that's conditional elimination, lines 1 and 2. And we still want to get not P here, but we're kind of stuck. I mean, there's no other non-subderivation rules we can use here. what we need to do is, well, okay, so one thing that we could do is try to do it by disjunction elimination on line 3, and that would that might get you there, but it doesn't look like there's any direct way from, we can obviously get from not P to not P, but I don't think there's any way to get from Q to not P, right? So oh, excuse me. There we go. Okay, so forget everything I said for the last minute. Sorry about that. Line 3 should be this. Okay, so we don't have a disjunction. Yeah, I started to wonder about that. It didn't look valid. It's because I forgot to put these parentheses around line 3. So with that, I mean, I'm sorry about that, but that underscores the importance of making sure that you don't forget about your parentheses, right? That definitely changes the nature of what we're doing here. So anyway, we don't have any, there's nothing we can do with lines 1, 2, or 3 anymore. We're stuck. We need to get to not P. All right, so what we're going to do is we're going to assume P. So we assume the opposite of what it is we're trying to prove. If it has a negation on it, we assume it without the negation. If there is no negation, we assume it with the negation, but we assume the opposite, and we're going to try to derive a falsum. Okay, so we need to get something in its opposite. In other words, we need to get something and then that same thing with the negation on it. So what you want to do is look at what you have and look for anything that has a negation on it. What do we have that's negated? We have line 3. So I hope everybody can see that, why I'm signaling that line out. So what we want to do is try to get the opposite of what's on line 3, which is P or Q, right? Because we have not P or Q on line 3, and then we're going to get our falsum. So I hope that everybody sees how to do this. It's that rule that everybody always forgets about. Okay, so there we go. We have P, R, Q. Now we have falsum by negation elimination, that oddly named rule. Lines 3 and 5, and now we have not P by negation introduction, lines 4 through 6, and finally we have this now by conditional introduction, lines 2 through 7. All right, so before I wrap this video up, let's just take a look at one more way to do this. So we have if A, then not P or Q. And we are trying to get if A, then not P. Okay, so whether you're working with the new rule, with the derived rules or not, this starts out the same way you would always start. You assume A, and you're trying to show that not P follows. But hopefully everybody can see that this is a setup for doing De Morgan's law. So we do conditional elimination, lines 1 and 2, and now we do De Morgan's on this to get not P and not Q. So it's De Morgan's law on line 3, and now we have this just by conjunction elimination on line 4. And finally, conditional introduction, lines 2 through 5, we can wrap that up. So, again, that's not drastically shorter, but some people just find that to be conceptually easier because it doesn't involve De Morgan's law. Okay, so I'm going to go ahead and wrap this video up. I hope everybody got something out of it. I know I flew through that a little bit briskly. I mean, I do have other stuff to do this weekend, but, it's recorded, so you can go back and take a look at those parts that might have gone by a little fast. Everybody take care, and I'll see you next week. I am going to record one more video on the homework.